Okay, hopefully you remembered excuse me. Hopefully you remembered your note packet. Just as a reminder, whenever we do a video, it'll usually be an entire section, but every section's not very long, because my goal is to make the video no more than 15 to 20 minutes. We're going to start with some just basic things about angles, and then a new way to measure angles, which is radians. Because I want to make sure everybody's on the same page. So for A1, I can draw an angle in standard position when it is in radians and degrees. I can convert between radians and degrees, so we'll do that. And then how to define radians in terms of arc length and rotation. And then for A2, I can define reference angles and coterminal angles. Again, what's in bold, if you can do that, then you're proficient. And then if you can go a step further and do what's labeled as a 4, then you're over and beyond and you would get a 4. Alright, so today we're starting the journey into trigonometry. You've done an activity in which you investigated a periodic function. How would you define a periodic function? We kind of talked about this yesterday, but a periodic function is a function that repeats a pattern. Okay? So it repeats a pattern, but the pattern is special because the pattern it repeats, function that repeats a pattern, is cyclical. Which means it's the same exact pattern over and over and over again. This type of pattern usually involves theta, which is our notation for when an angle is in degrees, or x, which is our notation for when an angle is in radians. Now, I know we haven't really talked about what radians are yet. A lot of you have been exposed to what radians are in Algebra 2 or in another class, but those are the two ways that we're going to measure angles. Just at the very top here, I'm going to write some of the symbols that we used. A 0 with a line through it vertically is the Greek letter phi. That's a common variable. This one's probably the most common variable we use. Theta. Alpha, which looks like a fish. And then beta. These are pretty common variables that are used to represent angles. Alright, in the Ferris wheel problem, you saw that you could use an angle to measure an amount of rotation. In this section, we will talk about angles whose measures are greater than 180, and why functions such as your height above the ground are periodic functions of the angle through which the Ferris wheel rotates. Meaning, as the Ferris wheel rotates, it's affecting the height above the ground, but your height above the ground, as the wheel rotates, goes through the same pattern over and over and over again. So like you hit a height of 20 feet, you're going to go around the circle again and hit the height of 20 feet again. Up to this point in your math, your major exposure to trig has been associated with triangles and degree measure. However, in situations that are, I did forget what I was going to put there. However, in situations that are, I guess this will work. I'm pretty sure that's what I meant to put. However, in situations that are repetitive, trigonometry plays an important part. Excuse me. We will get into this more when we discuss the other angles, or other ways angles are measured by length. An angle measure of rotation can be as large as you like. Before we get much further, though, we'll need to define some terms so that everyone is on the same page. Alright, standard position of an angle. You draw an angle. Where the angle starts is called its initial side. Where the angle ends is called its terminal side. The angle can open up or it can open down, but it always starts from what we call, if this was in a circle around the axes, it's always going to start on the positive x-axis, and then go from there, either open up or open down. We usually label that a theta, or x, but we label the angle with some variable. Standard position means that the vertex of the angle, which is the point where the two sides connect, vertex is at the origin. The initial side is along the positive horizontal axis. If you open counterclockwise, you have a positive angle. If you open clockwise, you have a negative angle. Okay. Some other terms we have to just be clear on, or at least be on the same page. Coterminal. 2 words. Co means with. Terminal means terminate or end. So coterminal angles are 2 angles or multiple angles that end in the same spot. Coterminal angles have, well, I guess we'll say that, 2 or more angles that end in the same spot. They have degree measures that differ by 360 degrees. So if my new angle, or my coterminal angle, if we labeled that as phi, you can get the value of phi, or get the value of coterminal angle by taking the original angle that you're trying to find a coterminal angle of, and add or subtract 360. And the reason I write it as 360n is to represent trips around the circle. So 360, 1 rotation. That times 2 is just 2 rotations. That times 3 would be 3 rotations. So you can have an infinite number of coterminal angles if you really wanted. Okay, now reference angles are going to play a key part in many sections that we do. We talk about reference angles quite a bit. These are angles that are formed between a terminal side of an angle and the theta slash x axis, or the horizontal axis. Some key things here. Reference angles are always less than 90. The reason these are helpful in lots of different situations that you'll see, I mean they'll keep popping up, is that they do allow us to have a reference point. So instead of dealing with an angle that's maybe over 2,000 degrees, we can use the reference angle to find the same value as using the very large angle. So it usually simplifies the process if there is a reference angle. Reference angle is always positive, no matter what. And the last thing is that angles that land on an axis, so angles like 0 degrees, 90 degrees, 180, etc., do not have a reference angle. Okay. I want you to make an A and a B and a C for example 1. We're going to do A and B together. And then C we'll come back to after we talk about radians. Okay, for example 1. If we're going to graph, we're going to do 3 things here. Because I believe the standard, you need to be able to draw an angle in standard position, and then you need to be able to convert between radians and degrees, and you also need to find and define reference angles and coterminals. So we're going to do a couple of things here. We're going to sketch it first, then we're going to find the coterminals, and then we're going to find the reference angle. We'll just abbreviate that as reference angle. Okay, now to sketch it. Remember, we start at the positive x-axis. It's a positive angle, so we need to go counterclockwise. One trip around the circle is 360. Now to figure out how much more you have to go, I usually take 475, subtract one way around, 115. I know this is 90. I know this is 180. So 115 is going to be about right there. To sketch it, you need to make sure that you show the little swirly there in order to show where it ends and how many times you've gone around. And then this is quadrant 2. Knowing what quadrant angles end in is also important. Now, coterminals. The easiest way to find a coterminal is to take 475, the angle that you're given, and subtract 360. So I already saw that when I subtracted 360, I got 115. If I add 360, I get 835. Okay, so these are my two coterminals. If I was to sketch either one of those, they would end in the same spot as this angle. Now, reference angle. Reference angle is the angle between the horizontal axis, so my x-axis, and the terminating side. So I have to figure out what that space is, and that's my reference angle. To figure out what space that is, I know that this is 180. I know that this right here was 115, because when I took away a trip around the circle, I was left with 115 degrees. So I'm going to take 180 and subtract 115, and I get 65. Alright. We're going to do the same thing, but now we're going to go with negative 540. Okay. So again, we're going to find coterminals. We're going to find a reference angle, and we're going to sketch it. Now to sketch it, we start at the positive x-axis, and now that it's negative, you're going to go clockwise. So one trip around, I'm going to take 540 and subtract 360, and I'm left with 180. So I know that I end right there. Now, we're not in a quadrant because you're on an axis, so there's no quadrant to label. For coterminals, you find them the same way. So we're going to add and subtract 360. If I take 540 and subtract 360, you get negative 900. If you take negative 540 and add 360, you get negative 180. There's my two coterminals. My reference angle is the space between the horizontal axis and your terminating side. But because the terminating side is on the x-axis, you have no reference angle. Okay, you're going to get more practice on this, obviously. And I know some of you are going to be pretty comfortable with this, but some of us needed to either relearn it, relook at it, or maybe you're learning it for the first time. So be patient with each other when we do practice it. Go ahead and slow it. Okay. Now, we're going to talk about radians. Let me just check the time here. Okay, this might be a 20-minute video, but that's okay. We're going to talk about radians a little bit in this video. You'll have more opportunity tomorrow to investigate what they are, but at least we can do something with them today, because I know some of you already know what these are. Alright, so what are degrees? Where did they come from? Degrees came from ancient math dudes who divided a revolution. Now, when I say revolution, I'm talking about, like, if you're looking at a circle, one rotation around. So they took one rotation around and divided it into 360. Now, the reason they took one rotation and divided it into 360 degrees is because in their calendar there were 360 days. Now we know that our calendar is actually 365 and some change. And in order to reset our calendar so it's properly linked with the seasons and stuff, and the moon and that kind of stuff, that's why we have leap year every 4 years, is to make that adjustment, because we lose minutes every day. And if we never had a leap year, then our summer months would probably end up being in the winter months. So like during the summer, instead of being nice and hot, it would be actually cold, because it would throw, like eventually those extra minutes would build up to throw off our whole calendar. But that's why they use degrees, because to them it made sense. Okay, one rotation around the sun for the Earth takes us 360 days, so we're just going to make 360 degrees represent that. Radians, however, allow us to work with situations that actually model more real-world phenomena. When you're talking about degrees, you can have degrees of rotation in a circle, but you're still talking about an angle in a circle of rotation. If we're talking about a periodic function, maybe not something that's spinning, but something that just keeps repeating, like a pendulum or the tide or anything like that, that just keeps the same pattern time after time after time and just keeps repeating, not necessarily in a circle, but just keeps repeating. We need something to measure that, because 360 degrees of rotation, that's a repeating type of phenomena. But there's other types of repeating phenomena that we need to be able to do something with and measure. So, what is a radian? A radian is an angle measure that associates radius length to the arc length. This is different because we're talking about length. So with a radius, or with a radian, well, I guess let's go up here. If you have a circle and your radius is this length here, one radian measure, okay, so like everybody kind of knows a degree is barely even anything, because there's 360 degrees in this whole thing. But if we're going to measure 1 radian angle, you're basically taking the length of the radius, you're stretching it out on the arc length, and then where that stops, so if you took this radian length and you stretched it out on the arc, wherever that stops, that's 1 radian. So 1 radian looks quite larger than 1 degree, because it's associating the length of something, not just how many degrees you're rotating through. Radians allow us to model real-world phenomena where independent variables so these are variables that, like x values, independent variables, represents distance, time, etc. Any quantity that can be measured no longer do we have to just stick with circular rotations. So it expands from circles, which is more the degrees, or triangles, which is degrees. So expands it from shapes to actually real-world phenomena that repeats. All right, how to convert between radian and degree measure. Oh, and I'm at 20. Let me make sure I'm not. Okay, we're going to do example 2 and 3 together because these are pretty quick. How to convert between radian and degree measure. To convert from radian to degree. Multiply by 180 degrees over pi radians. Now, this isn't going to make much sense unless you've seen it before. This pi radians isn't going to make much sense until we look at what we need to tomorrow. So for right now, just know that that's how you convert. We're going to practice it today. Degree to radians. Multiply by pi radians over 180. Technically, this fraction is a fancy form of 1. So you're not changing anything, you're just changing the way that it looks. Okay, so the first one we're going to do here is we're going to convert 540 degrees. So to convert to radians, which is the other way to measure angles, we're going to multiply this by pi radians over 180. Now, when you write your final answer in radians, notice the degrees will cancel. If you can reduce that, do it, which I think 540 divided by 180 ends up being 3. So you can cross-reduce it if you want. And then your answer here will be 3 pi radians. Okay? And then, for example 3, if you make an A and a B, if we were to convert 3 radians to degrees, you do the opposite. You're going to multiply by 180 over pi radians. Now your radians, unit of measure, will cancel, and you're left with 3 times 180, and then divided by pi. And you end up getting 171.887 degrees. So I multiplied 3 and 180 and divided by pi. And then for B, if you have negative 5 over 4 pi radians, so this is a radian measure, to convert to degrees, you're going to multiply again by 180 degrees over pi radians. The radians cancel. The pi's end up canceling, and you have negative 5 times 180 divided by 4. And you end up getting negative 225 degrees. Okay, that'll be where we stop. I know we have example 4, but we're going to actually use that as part of our whole group review tomorrow.